Hi everyone. Today's goal is comparing and ordering fractions, also called rational numbers, and to find and estimate square roots. When you're comparing two fractions, you want to start by multiplying opposite denominators and numerators. Some people refer to this as cross-multiplying. So here's our denominator on the bottom, and we're going to multiply it by the numerator on the top, and we end up with 10. Here's our denominator, and we're going to multiply it with the opposite numerator, 3 times 4, and our answer is 12. Next, we're going to compare those numbers. The larger product, in this case 12, will be written above the larger fraction. So 4/5 is greater than 2/3. Fill in less than, greater than, or equal to between the two numbers to make the statements true. Pause the tape until you are done, and then press play to check your answers. Five sixths is less than 7/8. 2/15 is less than 1/6. 3/10 is less than 5/14. 5/8 is greater than 7/12. 3/8 is equal to 6/16. 3/5 is greater than 5/9. There are 3 ways to order fractions. The first way is you can compare each pair of fractions individually. So if you're asked to order 3/4, 2/5, and 1/2 from least to greatest, you can think, use your brain. Almost everyone knows that 1/2 is right in the middle. So now let's look at the other 2 fractions we have. 3/4, well, half of 4 would be 2. 3 is more than that, so 3/4 is more than 1/2. And then 2/5. Half of 5 would be 2.5. 2 is less than that, so 2/5 must be less than 1/2. The second way is you can find the lowest common denominator, or the LCD, and make equivalent fractions using that. The least common denominator is the lowest common multiple of the numbers. So here's our fractions again: 1/2, 3/4, and 2/5. Multiples of 2 are 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and the list will continue going on. Multiples of 4 include 4, 8, 12, 16, 20, 24, 28, 32, and so on. And multiples of 5, 5, 10, 15, 20, 25, 30, 35, etc. The least common multiple, or the lowest common multiple, of these 3 numbers is the first multiple that ends up in all 3 lines. In this case, it is 20. So 20 becomes your denominator. Now you need to go back and think, what did I do to 2 to change it to 20? Well, we multiply by 10. If we multiply the denominator by 10, we need to multiply the numerator by 10 as well. And the number in this box should be 10. Our next fraction, 3/4. 4 times 5 is 20. 3 times 5 is 15. Our last one, 5 times 4 is 20. So we need to multiply 2 by 4, and the number up here should become 8. Now, since they all have common denominators, you should be able to easily put them in order. 8/20, 10/20, and 15/20. When you write the correct answer, however, you want to use the original fractions. So instead of writing your answer in this form, you should write it in this form: 2/5, 1/2, and 3/4. You can also change your fractions into decimals. This is very easily done when you're given a calculator. It does require a little bit more work if you don't have one. And you also want to be very careful with your negatives. Remember, -8/10 is actually less than negative 2/10. It's always the opposite of what you think it will be. Place the fractions in order from least to greatest. Write these 5 examples down, stop the tape, try them, and then press play again to see the answers. Number 1, number 2, number 3, number 4, and number 5. Perfect squares. Here's some examples. 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, and we can continue on. A perfect square is a number that is the product of a number times itself. So 0 is the product of 0 times 0, 1 is the product of 1 times 1, 4 is the product of 2 times 2, 9 is the product of 3 times 3, 36 is the product of 6 times 6. I strongly suggest you write these first perfect squares down from 0 all the way up to 225 and commit them to memory. It will definitely help you. A square root is the opposite of a perfect square, or the inverse. The square root of 9 is equal to 3. It's also equal to negative 3, because if you recall, a negative times a negative, in this case negative 3 times negative 3, is going to give us a positive 9. The principal square root is a positive answer. For the purpose of this course, we will almost always be using the positive square root. But I do want you to know that, or remember, that you can also have a negative square root. Here's some practice for you. Find each square root. And here's your answers. Again, because it doesn't specify the square roots as plural, you would only list the principal square root, which would be the positive answers. Find each square root. Treat fractions just as if we had a square root of 1 in the numerator over the square root of 4 in the denominator. Notice the negative sign is out in front of the square root sign. The negative is just going to float along with your answer. So 17 is equal to negative 1/2. The square root of 1 is 1. The square root of 4 is 2. And 18 becomes 9 over 11. The square root of 81 is 9. The square root of 121 is 11. To estimate square roots, you're going to use the closest perfect squares. So in our example, we're looking for the square root of 27. The closest perfect squares are 25 and 36. The square root of 25 is 5, and the square root of 36 is 6. 27 is much closer to 25 than it is to 36. So we're going to estimate our answer at approximately 5 2/10. And notice it's not an equal sign that I'm using, it's a squiggly one. A little poorly written, but it's the best I could do with the Smartboard application. Our next example is the square root of 62. The nearest perfect squares are 49 and 64. The square root of 49 is 7. The square root of 64 is 8. 62 is much closer to 64 than it is to 49. So your answer is going to be approximately 8. It would also be acceptable to put approximately 7 9/10 if you wished. Find each square root, round to the nearest whole number. Be careful of the negatives and watch your rounding as well. Stop the tape, try them, and then press play when you're ready to go. Notice on the answers, number 10, number 14, and number 15 all have equal signs. They are not about 12 for number 10. The square root of 144 is 12, so you would use the equal sign there.